Hello? So we're trying to catch up on time, so let me try to start quickly. And my job is called InnoDB Performance Tuning, but I thought in like 25 minutes we better call it Introduction to InnoDB Performance Tuning. So I will just cover basics and which you have. So when you look at the InnoDB tuning, there are a few different things which we can speak about. That's tuning MySQL settings, MySQL schema, operating system, and hardware and application. And well, we have 4 points, so we have about 5 minutes for each of them. So we should be doing pretty quickly. So MySQL settings, they are. It's very important to adjust them, in particular for InnoDB table, because if you're using MySum, well, it actually runs pretty good with defaults. With InnoDB, well, the defaults are bad. You know, for 8 megs for buffer pool, 5 megs for logs. Well, that's like, unless you have some really toy database, it will be very, very slow. So the most important settings to set for InnoDB is InnoDB buffer pool size. And InnoDB uses buffer pool for a lot of stuff. It uses InnoDB buffer pool to cache data and index pages, and it keeps here all the kind of additional structures like logs, adaptive hash, insert buffer, undo, and now after you figure out. So how to figure out how large buffer pool do you want to have for InnoDB? Well, the idea is figure out how much stuff do you need for everything else and allocate the rest for InnoDB buffer pool. And that typically often can give you like 80% of your memory size, sometimes more, right? And I would say operation system is pretty much like relatively fixed amount of space, right? Even if you have 128 gigs of RAM, you probably don't need more than a few gigs for operation system itself. Then there are some per connection settings, right? And each MySQL connections may need 256K, maybe up to 1 meg. So you can count on that. And well, there could be a few other buffers like eCache and temporary tables which you use in your application. And the rest is InnoDB buffer pool. What is important to note here is what InnoDB buffer pool you specify in the MySynapse is not the amount that InnoDB is going to allocate. Depending on the platform and depending on the version, the overhead can be different, but it can be as much as 10%. So you say 20 gigs, well, InnoDB may allocate 22 gigs. And this confuses a lot of people because when you are getting very close, you can get swapping much earlier, right? Or you can see the MySQL taking much more space than you anticipated. Because, oh, I just started MySQL with InnoDB buffer pool, and where do those extra allocation come from? Now, also I would note, this of course applies to large installations, right? I assume your data is large. If your InnoDB data size is small, it doesn't make sense to have an InnoDB buffer pool larger or much larger than your InnoDB data size, right? So watch out for that too. InnoDB log file size. Now, if you have any intensive writes, then InnoDB log file size is very important, because the larger are your log files, the less data flashes you'll have to do. Pretty much every single page in the buffer pool, which it gets modified, have to be flashed at least once per whole cycle of log files, right? But at the same time, the larger log files you have, the longer recovery time you will have in case InnoDB crashes. So those are trade-offs you typically deal with. One more interesting kind of advanced thing I would note, but when you get very large log files, the performance may actually go down a bit, because as InnoDB cycles through log files, it is a bit faster if your log files fit in cache, right? Because InnoDB log files, they are not the log page size is actually just 512. And the file system block size is typically 4 kilobytes. That means as you go through the logs and write those small chunks, you may need to do read before you can write the data. Right? And if your whole logs fits an operation system cache, then that means it's cool. You don't have to read the data before you overwrite it. So that's kind of a little optimization which can cost you a few percent sometimes. How do you practically define how large your log file should be? Well, look at the time it takes to recover, and this is, you can just like run your favorite workload and kill -9 MySQL or shadow power and see how large it recovers, how long it recovers, repair, do it a few times and see, well, max times, and then size the logs appropriately. Redo phase of InnoDB recovery is pretty much proportional to InnoDB log file size, so it's very easy to size it. And we don't have time because I can talk a lot about this. One little interesting thing here is about InnoDB recovery. This is exactly the thing that large buffer pool is not always better. There is a bug, or you can call it a feature. Oracle calls it a feature in the InnoDB, which makes recovery slower with a large buffer pool size, because there is pretty much some linear scans inside for some things. So in some cases, if you can see your recovery CPU bound, right? No, CPU bound, not IO bound, then you may get better recovery speed by reducing buffer pool sizes, which is very counterintuitive, but that's how things are right now. And you can look, there's some bugs about it before. So, but going back to size and log files, another way to size things is to look at the amount of data written to the logs. Right? This is called InnoDB OS log written. And you can see, well, how frequently it takes to cycle through the log files. I would say if it takes an hour to cycle through the log files, you probably don't need large log file size, right? Another important option is InnoDB flash log at T-Rex commit. And this is not truly just optimization options. It is the option which defines how much do you care about your data, right? And do you really want, if the data, if transaction is committed, it is committed, or you don't really care? In case you have one, the InnoDB will fsync logs at each transaction commit, which if your hardware doesn't lie, means the data should be guaranteed, it should be durable. Now there is value 2, which only flashes log file to operation system cache. And this gives you another level of safety, meaning if you kill MySQL, if MySQL crashes and or operation system survives, the data will be also committed. It will be fine. And then there is also value 0, which says, hey, just keep the stuff in memory, in MySQL memory, and don't bother flashing it at all. It will be still flashed in the background, and it flashes a log file about once per second, but in this case you are likely to lose the data for last seconds or maybe last few seconds in case MySQL is crashes or killed. And if you or use a replication, I would note you also should be thinking about sync bin log, because otherwise you will likely be in an interesting situation. If power goes down, you will have the data in a DB transaction, but it won't be in binary log. So your slaves will miss certain transactions. And even if you don't just have slaves, but just use binary log for point in time recovery, then those transactions will be missing from a binary log. So if data safety is paramount, you need to use this option, which causes pretty bad overhead as well if you don't have a battery backup hash. So another important variable which we set often is InnoDB flash method. And this defines how InnoDB flashes data to a disk. By default, it will use fsync. Actually, it will write a double write buffer, call one fsync after doing it, storing it in the disk, and then it go through and write files, write pages for each of InnoDB table spaces, which you can have one or many, calling fsync after each of those. Right, so that's how it works. Now, another option, another useful option, I would say, is ODirect. In this case, it says, hey, bypass operation caches, both for reads and for writes. And this is very helpful because it allows you to avoid double buffering. The double buffering is not the same as double write, right? Double buffering means that your data caches in two places, an operation system cache and an InnoDB buffer pool. That means you're wasting memory, and which is typically bad, because you want your operation system cache for other things like my sum tables, maybe some files, binary logs, and stuff like that. So, what is wrong with ODirect, however, is it's synchronous. So it may slow things down if you don't have RAID with battery back up cache. And also I would note for ext3 has inode level lock-in for physical I/O operations. That means there could be only one outstanding write per file, and also it's kind of a read-write log. So while there is write going on, you can't read from the same inode, which can be quite nasty. If you use XFS, that's not a problem. And really, this problem doesn't show up that much if you already have battery backed up cache, because in this case, writes are very quickly, right? They are just stored in write cache. You get acknowledgement in like fraction of millisecond, and then the rest happens like behind the scenes. Other helpful options. It is InnoDB file per table, which allows you to keep each table in separate file, which is helpful for various maintenance things. In particular, you don't have these problems of, oh, my InnoDB data file grow too large and now takes whole disk space, and I dropped that error table, but I don't have a way to get my space back. InnoDB thread concurrency, it restricts the number of threads in InnoDB kernel, and I would say sensible values is either setting it to 0 to disable it, or values like from 8 to 16 can be reasonable values if you want to restrict concurrency. Things are getting better with new InnoDB patches, and you may not need this to use this variable very frequently. InnoDB log buffer size, that's another interesting one, which defines amount of data which can be kind of buffered in memory before it has to be flashed to the disk. And we should note the log is flashed either on each transaction commit or at least once per second by background thread. So I see a lot of people saying, oh, what if I allocate 1 gig of memory to the log buffer size? Well, you can, but there is absolutely nothing to gain in this way for most applications. I would watch amount of disk written amount of data which you have written in a disk on average, and maybe multiply this value by 10, right, to accommodate peaks. And this is probably as much as InnoDB log buffer size as you would ever need. I would say the only real need to push it higher than like 10 megs or so is when you are working with large blocks. I mean, I've seen some people pushing, 10, 20 megabytes blobs in InnoDB, and in these cases you can write as much as 50 or 100 megs a second. And to avoid excessive flashing, you may want to have InnoDB log file quite large. Yes. What? Sorry?
Some people suggest to use log buffer should be half of your InnoDB.
Well, no. Well, there are some notes in the manual about InnoDB log file size being half of InnoDB buffer pool size. But this is from our old 32-bit days. Then disks were large and memory was small. And now you simply can't physically do it because the maximum size InnoDB allows for your logs is 4 gigs, and unless you're extremely unhappy, you probably have servers with much more RAM right now.
In official time, you finished about 3 minutes ago, but you started 15 minutes late.
Okay, sure. Yeah, I'm just trying to. So I have like 10 more minutes, right?
Well, Peter, maybe not. You're needed out here before too long.
What? Okay. So I never can get when you're joking and when you're not.
I'm not joking.
You're not joking. Oh my God. I'm in trouble, guys. Yeah, that's our COO, and if he wants me out, then that must be something serious. Okay, yeah, but we can just ignore him and continue. So then the cool stuff is some extra backup options. That is what InnoDB storage engine by Percona. And I only mentioned a couple of cool stuff, which is extra undo slots. This allows you more than 124 concurrent operations, which are kind of restricted in the InnoDB. It pretty much cannot try to run more than this amount of transactions which modify the data by default. And some people run into that. So we increase it to about 4,000. Now you can also have an increased number of background threads for reads and writes. That's helpful for some workloads. What also is very helpful for new storage subsystems is to increase InnoDB I/O capacity, which is basically a number of IOs a second we expect I/O subsystem to be able to handle. And by default it's just 100. It applies like to one slow desktop hard drive, and you can increase it, and InnoDB will change certain what it thinks like it has a lot of I/O to do and what's not. And InnoDB adaptive checkpoint, and that is very helpful thing what we've done. I mean, in many cases you see like throughput for InnoDB in benchmark and stuff like that, but if you would graph it like TPCC results, for example, or DBT2, you would see what InnoDB like goes well, and boom, like it almost stalls for quite a while. Oh, and this is happens like at the because you were doing so much writes, so InnoDB kind of cycled through and about to overwrite the log files, but it can't. It has to flash a lot of stuff before it can continue, so it blocks all the writes. And that may cause like hiccups and stalls for like 10 seconds or so. In our implementation, we have this kind of more eager checkpoint, and so as we are moving closer to this boundary, we start doing flashes more and more aggressively, trying to avoid this running into the wall. And I think this allows to even out things a lot. If you're interested in a benchmark graph, you can grab this or search for stuff in MySQL Performance blog, and there are some fancy graphs out there. Schema. Oh my God, that was just one section. And okay, yes, I will be surely out of time. I never got used to speaking less than an hour about InnoDB optimization, so that's tough for me. Clustering by primary key. I guess you guys all know all this stuff. And you can basically define your schema by getting advantage of clustering by primary key. What also that means is what using random primary keys like MD5 or something like that is very bad for InnoDB, because it just makes InnoDB to constantly do this page splits for cluster index, which is bad. Indexes. InnoDB indexes are larger than MySum. Be easy on them. Keep primary key short, because primary key is effectively part of every index. Also mind what unique indexes are expensive, because they don't use insert buffers then you insert. So try to be easy on those. Blobs. Beware of large blobs, because blobs are which don't fit to the page, they're stored outside of the page and are not very efficient. Also, it's worth to know what each blob is stored in its own segment. So if you have a row with a bunch of blobs, you pretty much get fragmented rows, and if you happen to fetch it completely, it will have to read the row page and then go to different location for each of the blobs, which is quite inefficient. The good optimization for InnoDB, however, is if you don't fetch your blobs in your select list, InnoDB doesn't go to read them. Operation system and hardware. Well, I would say Linux is most commonly used these days, and I think InnoDB runs pretty well on Linux. I think it runs pretty well on Solaris these days too. Sun did a pretty good job optimizing that stuff, and so you have direct I/O support now with Solaris and stuff like that. I would say using recent operating system version helps. There are a bunch of optimizations in the recent ones, like in particular if you use some like Percona patches of 5.4 stuff with atomic buildings and stuff like that. There's some it's good if operating system support for these things. Also hardware support can be improved, and that may speed up your disk controller stuff and that one. Now, fast CPUs, larger caches, always good. Now, how efficient multi-core user are going to get? Well, that is very much depends on the workload and depends on the version you're using. Right? Let's say if you haven't using Google patches, Percona patches, or MySQL for 5.4, you may have much better luck than with some other stuff. Now, unless you are using very small database, it's very important to use 64-bit hardware, 64-bit operation system, and 64-bit MySQL binaries. We really want me somewhere. Okay, so.
Do you want me to take your phone?
Oh, that's fine. We'll leave you a voicemail, so we'll have noisy SMS message to come soon. So, obviously, 64-bit allows you to have much larger buffer pool and generally use memory efficiently. If you investing in RAID, the battery backed up unit is important if it's write-heavy workload, and I mean, battery RAID with BBU is cheap these days. So I think if you are intense or you're IO, really good. Okay. Now memory. Again, I would say for a lot of guys, the solution is simply keeping their data in memory. And it solves a lot of performance problems with InnoDB. Now, I would say also flash storage and SSDs starts to look very attractive. I have some price points in my other presentation, and I think that's very nice. Now, RAID 10, they're most efficient, in particular if you have heavy writes. RAID 5 can be doing quite well for reads, but for writes it's not so good. XFS file system, we had very good success with that for a variety of customers, and particularly for you have multiple IO devices because of this mentioned XFS, the exe3 serialization issues, and we had some other performance issues with that as well. Applications. Okay, I got like 2 minutes, so we'll be very fast. Using transactions, well, the idea here is if you do a lot of updates with after commits, that is bad, right? So it's better to run transactions of a reasonable size, because long transactions is bad because they have a lot of accumulate a lot of garbage during their execution, but very short transactions means there is a lot of commit overhead. MVCC, get advantage of that. For example, you don't have to chop your selects and keep them small, short as with MySum because of table logs. Well, selects don't block anything, so you can run selects while other stuff is happening. Do not use log tables. I mean, there's a lot of legacy applications which are designed for MySum and still do use log tables, because even if InnoDB doesn't use table level logs, that doesn't need table level logs internally, log tables do log tables completely, so it can restrict your concurrency dramatically. Okay, last slide. That's very cool. Updates, deletes has to be fully indexed, because that allows us to get optimal locking. InnoDB logs all the rows it traverses, and if you have non-indexed delete or non-indexed updates, that can be rather inefficient. Watch out for deadlocks. If you're moving from MySum, for example, you may not know what there are such as deadlocks. Well, with InnoDB, for many applications, deadlocks happens sometimes sooner, sometimes later. And I would say unless this is a read-only query. It is good to have your application to be ready for deadlocks and simply retry transactions that happens to do something else. To minimize deadlocks, you may want to keep the log order the same across transactions, because if you log rows in the same order, it's just going to be a bit of a row level weight, and if it is if it is a different log order, you get the log order you get in the deadlocks. Select for update. Oh my God, I really want. Am I being fired? Okay. Okay. Yeah, somebody really wants me. But anyway, you got the point. Select for update, every cool stuff. Get log restricting concurrency, and I would also mention from the login perspective, it's important to be with foreign keys, because foreign keys make your login very complicated, and then you're thinking you're just logging, updating the date in this table, you're logging just one row, so it's been updated. It's like, because of foreign keys, your log may cascade, and it can be unexpected behavior. Okay, guys, so that's it. Because somebody is waiting for me, I've got to run, but I will be here for another talk, and we have this other cool stuff in the evening. So if you have some questions for me, I will be ready to answer just later.